This is our next question. And as we can see, there are four equations. But don't let that worry you. You know, as Mr. Romero always says, we need to start in the beginning. So if we analyze, there are four equations. Now let's start with the given information. So as we can see, we need zinc, we need sulfur 8, but there's only one of them technically. We need 2 oxygens, and we need zinc sulfate. Now, the first equation, if we look at it, we have the zinc in the right place, we have the sulfur in the right place, and then the zinc sulfide is unneeded. So that equation number 1 is perfect. Now, equation number 2, we have to look at it to analyze it. And when we look at it, we can see that we have zinc sulfide, which is unneeded. We have 3 oxygens, which is needed. And then we have zinc oxide and sulfur oxide. These two are unneeded, and the oxygen is in the right spot, so that's good. So for now, 2 is good, but we might need to come back to get rid of this 3. Then we have sulfur oxide again, 2 of them. We have oxygen, and then we have sulfite, right? Now the only thing we need from this one is the oxygen, which is in the right spot. So for now, it's good. That's a terrible 3. And then number 4, we have zinc oxide, sulfite, and zinc sulfate. Only thing we need from this equation is the zinc sulfate, and everything else is kind of perfect because it's all 1 digit. There's no correspondence, whatever you call them. So that's perfect. Now for these 2 equations, we need to analyze, because if we look, we have 3 O2 and then we have O2. Now since they are on the same side, that means that they're going to combine to make 4 O2, which we only need 2. So we can multiply this equation by 1/2 and multiply this equation as well by 1/2 to then get the new equation 2, which is, let me put a period so we can split that, which is just zinc sulfide. Let me write the elements, I mean the type, 1/2 oxygen gas goes into zinc oxide solid plus sulfur oxide gas. And then we can worry about the delta H in a little bit. I'm just gonna write delta H2 equals, and we can worry about that after. So this is the new equation 2, right? And then we should write the new equation 3, which is sulfur oxide gas plus 1/2 an oxygen now. So we know what's the O. I'm gonna put a little dash through the 0. Gas, this is in the gas state, goes into sulfite, it goes into sulfite gas. And then same, I'm gonna put the delta H3. So by some quick math, and we divide by 2, the H3 should be negative 98.02 kilojoules, and the H2 should be negative 463.77. kilojoules. Right. So now we have the H2, the H3, and since we didn't change these are this is the H1 and this is the H4. Now, before we do anything, we need to analyze that this works. So this is perfect. So we could check this one off. We could check that one off. We can check the sulfur 8 off as well. Whoops, sorry, I went a little out of the box. Now we look at zinc sulfide, and we have 1 on this side and we have 1 on this side, which means that they can cancel out. So those are done. This equation is done. Now, as we said previously, this one, so we have half an oxygen, right? I mean, we have 1/2 oxygen, zinc oxide, and SO2. And then here we have SO2 on the opposite side, so we can cross them out like any other equation. And if you're wondering, you know, Matthew, how do you know about this? It's just like x equals, let's say, x plus 1, right? So if I have x equals x plus 1, you have common variables, which means you can subtract x on both sides to just get 1, right? So that's what I'm technically doing here. I have one sulfur oxide, and I have 1 sulfur oxide, because remember we did the 1/2. So, and they're on opposite sides of the equation, so we can just remove them from each other, right? Now, next, we have 1/2 an oxygen and 1/2 of an oxygen. And since they're on the same side of the equation, they add up to 2 full oxygens, which is right here. So let's just draw a box around these. Right. Then we have, you know what? It would be smart to get rid of these, because we already know what we did and they're just confusing. Right. And then we select, and then we just drag these up here. So I feel like this is a little easier on the eyes, even though it might not be for some people. So now we have zinc oxide and zinc oxide and 1. So we could cross those out. And now all we have left is the SO3, is the sulfite and sulfite, but they're on opposite sides of the equation, and as stated previously, common variables take each other out. So then we are left with zinc in the solid state plus 1/8 sulfur 8 in the solid state plus 2, because you add these, 2 O2 gas state goes into zinc sulfate solid state, right? So now we have the equation down, but now we need to add our H's to find HR. So we add negative 800. Wait, hold on. We add negative 183.92 plus negative 463.77 plus negative 98.02 plus negative 230.32 kilojoules, which gets you negative 976.03, right? Kilojoules. You might be wondering, what does this mean, Matthew? What does this number mean? Well, this is the HR, right? So the HR is negative 976.03 kilojoules. And this, who is calling me? Sorry about that. And this is the answer for this. So this equation up here, right? This beautiful equation up here is equal to this. So this is our answer. And yeah, so in the start this equation looked pretty difficult, right? But in reality it was quite simple. And so yeah, just always remember that variables on same side add, but on opposite sides cancel out each other, just like in algebra, which is not my parte.